Hello and welcome to today's lesson on light-dependent resistors and thermistors. Our two learning objectives are to use graphs to explore whether circuit elements are linear or non-linear, and use graphs and relate the curves produced to the function and properties of thermistors and LDRs. I'd now like you to draw a circuit diagram for the circuit that's shown in this picture. Pause the video if you need to. This circuit diagram should be familiar to you because it's the same one that we've used previously to investigate the characteristics of various different components. And here we have the correct answer. Compare this to what you have and make any alterations if you need to. It's very important that you remember this circuit diagram. What type of component will have a characteristic graph like the one shown? The answer is it's a resistor, although you could also have said a wire. Both have linear characteristics. Now see if you can identify this component. This would be a filament lamp, and you can see it's a non-linear component because as it gets hot, the resistance increases. And what component would this characteristic graph be for? This would be a diode, which lets electricity flow in only one direction. And finally, a slightly tricky one. What component would this be? It would be a filament lamp again, but in this case, the X and Y axes have been swapped over. I'd like you now to take a minute to think how a digital thermometer might work, or possibly a security light that comes on when it goes dark. These devices use components that change their resistance depending on external conditions such as light or temperature. These components are made using semiconductors such as silicon. Now, semiconductors are neither an insulator nor a conductor. Under normal conditions, the electrons are just too tightly bound for the electricity to flow. But if you give them some extra energy, either from light or heat, this gives the electron enough energy to escape, and then current will flow. Thermistors are made from semiconductors. They have a high resistance when they are cool, but when they get hotter, their resistance drops. We've already seen how you can use an ammeter and voltmeter to find the resistance of a component. But what you can also do is use something called an ohm meter. Now, an ohm meter measures resistance directly. So if you connect a thermistor to an ohm meter and then vary the temperature, you can measure the change in resistance with temperature. Or you can use a multimeter set to the ohm meter setting, as you see here at the bottom left-hand corner of the ohm meter. If we then use the results from this to plot resistance and temperature together, you would see a graph like this, showing very, very high resistance at low temperatures, but a reduced resistance as the temperature increases. The reason for this behaviour is that as the thermistor gets hotter, the electrons gain enough energy to escape from their atom in the semiconductor, and this allows more current to flow. So to summarise the behaviour of thermistors, for a fixed potential difference at low temperatures, the current is small, so the resistance is high, and at high temperatures the current is high, so the resistance is low. You'll find thermistors used throughout your homes in all sorts of electronic devices to measure temperature, from ovens to freezers to laptop computers to stop them overheating. For a couple of quick questions. What do we call the instrument that we use to measure resistance? It's called an ohm meter. And how does a kilo ohm relate to an ohm? One kilo ohm is equal to 1,000 ohms. Light-dependent resistors are very similar to thermistors. They have a high resistance when it's dark. But if you shine a light on them, the resistance reduces. As the intensity of the light increases, more electrons gain enough energy to escape their atoms, and this increases the current and reduces the resistance. Here you can see a comparison between the light-dependent resistors graph on the left and the thermistors graph on the right. I'd like you now to pause the video and have a go at this question in your book. The answer is that the resistance would decrease. Okay, pause the video one more time and have a go at this question. And the answer is that the current will increase because the circuit's resistance will decrease. Here we have a circuit with a thermistor in series with a variable resistor. There is a fixed potential difference of 12 volts across both components. Write a suggestion in your book for how this circuit could be used. Pause the video while you do. This circuit could be used to turn a device on or off depending on the temperature. Why do you think a variable resistor is used rather than a fixed resistor? Pause the video while you write down your answer. The variable resistor allows the temperature settings to be changed by changing the voltage drop across the variable resistor due to the size of the resistance of the variable resistor in relation to the resistance of the thermistor. That brings us to the end of today's lesson. I hope you found it useful, and thank you very much.